when you guys are done talking, so the way we're going to fill out notes here today is we're going to fill out a chart. First thing that's going to go on the chart is the one you guys already addressed as part of the daily question, and that is mass. Which ones are the massive ones? Protons and neutrons. Now specifically, they have a mass of 1 atomic mass unit. So 1 AMU. 1 AMU. And an electron has a mass of 0 AMU. Now, that's not to say that the electron has no mass. Electrons do have mass. However, it takes over 1,800 electrons to get the same mass as a single proton. And since atoms don't have literally thousands of electrons, we don't have to worry about the electrons having mass here. So it's really just very, very little. All right, next one up, charge. Which one's the positive one?
Proton.
Pretty much everybody gets that one right. Positive. There we go. I can't write. Now the next one, probably about 3 in 10 people get wrong. What one's the negative one?
Electron.
The electron. Negative. Remember that the neutron is neutral and doesn't have a charge. Next one up, location. Where would I find the proton located? In the center, which is called the nucleus. Okay, so nucleus, nucleus. And where would I find the electrons?
Like on the outside.
On the outside, which has a special name. Orbitals is a good answer. Think larger scale than orbitals. Because orbitals were small zones, right?
It's the floors of the thing, right?
Yeah, what was the
I
floors?
don't remember.
In the energy levels. So we said orbitals, we said in the energy levels. Orbitals and energy levels make up the electron cloud. Orbitals and energy levels are good answers. They're just smaller parts of the electron cloud. All right, next one up. Determines the element. Which one of these determines the element? Proton. Okay, next one up. Determines reactivity. That would be just the electrons. Electrons determine what an element will react with. All right, so we've got protons. Protons determine the mass, the charge, and the element. Electrons, what do they determine? Reactivity and what else could you find, or what else do electrons determine? Charge, good. So what are the neutrons good for? There's something. Mass, and we should throw the neutrons a bone. Give them something else here.
Their location. I don't know.
What else are neutrons good for that you found in the simulation on Monday? Making it stable. Determine stability. All right, and lastly, I do have one more row to add here. What? You wouldn't add that row? Took a couple people a little bit of time, but we're there now. Oh, yeah, that would make that more difficult. All right, so this table basically gives us a rundown of all the different aspects of the particles of an atom. However, there are two other terms that I want us to make sure we understand. The first one was the term for a charged atom, or an atom that didn't have an equal number of protons and electrons. What was that term? I heard it. Ion. And an ion is any atom with a non-zero charge. Any atom with a non-zero charge. Now, this can be made by either taking away or giving extra electrons. Created either by gaining or losing electrons. Was there another way in the simulation that you could have caused an ion to be created? Was there another way you could have caused an ion to be created in the simulation? How else could you have influenced the charge? Proton. All right. So we could add or take away a proton. However, we're not going to do that because adding and taking away electrons, that's very common. That happens all the time. Anytime you see a chemical reaction, we're exchanging electrons. They're moving around. However, if you try to take away a proton, it not only changes the element, but that's a nuclear reaction. If you add a proton, that's what the sun is doing. So you're releasing a lot of energy. If you take away a proton, that's what a nuclear bomb does. So we don't move protons. We leave them on the nucleus because moving protons releases incredible amounts of energy. So gaining or losing protons releases incredible amounts of energy. All right, so we can only create ions by gaining or losing electrons because the other option is way too dangerous. Okay? Next one on our list. It's another I word. This one, though, is isotope. Isotope. Isotode, like some kind of frozen frog? Okay, all right. So an isotope. Isotopes are atoms of the same element with different masses. Atoms of the same element with different masses. All right, and an example we can give of that is carbon. From the simulation on Monday, anybody happen to remember how many protons carbon had? 6. All right, it had 6 protons. It also normally has 6 neutrons, and therefore for a neutral atom would have 6 electrons. And we would say that the mass of this carbon isotope is 12, so we'd call this carbon 12, because it has 6 protons and 6 neutrons. Well, that's 6 here, 6 there, that's 12, and these guys basically have no mass, so we don't count them. Good? Okay, so the next part. How many of you have ever heard of carbon dating? Carbon dating. So a few of us have. It's a process that we use, especially in paleontology, to figure out how old something is. So if you had like a dinosaur fossil and you wanted to know how old that was, or maybe you had like pottery from an ancient culture, you could figure out how old it was based on how much or how many of these carbon-14 isotopes you could find. So when we talk about something like carbon-14, it still has 6 protons because it has to, otherwise it's not carbon. But now it also has 8 neutrons and still 6 electrons. So while they're both carbon, these are different isotopes of carbon because they have different masses. And they have the same chemical reactivity, they have a lot of the same properties. However, carbon-14 gets a bonus property of being slightly radioactive, because over time it'll get rid of these extra 2 neutrons and turn into carbon-12. Okay, so same properties, but certain isotopes may be radioactive. And it's not even like the super dangerous kind of radioactivity. It's actually kind of boring. It tells us how old they are, and that's a great tool for it, though. All right, questions about isotopes, ions, or anything from that chart that we filled out?